the ultra-competitive market for monopolar RF in South Korean aesthetic industry if you had to choose just one. It is a great honor to give a lecture at the 4th ICLIS conference in Seoul. I am chairman of the board of KALDAT in Korea, and I am a facial plastic surgeon. My main job is nose surgery and nasal reconstruction surgery, facelifting and rejuvenation. Nice to see you. Let's talk about monopolar RF that operates at 6.78 megahertz. As many of you may already know, Sumaji is a tool that operates at 6.78 megahertz and has gained significant popularity over the years. We have a Korean version of Thermage that also operates at the same frequency. In this lecture, we will dive deeper into the workings of Olrigio and discuss its various applications. So, without further ado, let's begin our discussion on Olrigio. Since its launch 1 year ago, over 500 units of Olrigio have been sold, and the sales have continued to grow, with approximately 900 units currently being sold. This remarkable sales growth has continued just over 2 years now. The fact that Olrigio has been selling so well suggests that it has some unique features and advantages over other similar tools in the market. Let's take a closer look at some of these features and explore how Olrigio works. One of the advantages of Olrigio is that it operates at a frequency of 6.78 megahertz, which it inherited from its predecessor, Essiomeiji. Olrigio has also made significant improvements to overcome some of the limitations of Essiomeiji. Such includes cooling system, moving technique with auto mode, and customizable time setting for the device's tips. Let's start with the topic of why 6.78 megahertz is chosen as the operating frequency for Olrigio. As we can see from the formula, the penetration depth of a high-frequency device becomes shallower as the frequency increases. In the case of bipolaris, as in this image, there are two different frequencies, 0.8 and 2.45 megahertz. The higher the frequency, the more superficially the high frequency and heat are injected into the skin. I'm sure you are wondering why Essiomeiji and Olrigio chose 6.78 megahertz when we have other higher frequencies, such as 1 megahertz, 4 megahertz, and 3.4 megahertz if we want to target deeper tissue. Let's talk about that now. That's because of capacitive reactance, which is a resistance that exists in a dielectric material. In our case, the epidermis and chromium basement membrane act as a type of resistance. As the frequency increases, the capacitive reactance decreases, allowing current to flow more easily. So, in order to achieve a deeper penetration, we need to ensure that the current flows well through the epidermis and basement membrane, which can be accomplished by increasing the frequency as high as possible in consideration of the depth. Reasons we cannot use highest frequency is because we must use only authorized frequencies, because when alternating currents move electrons, they create electromagnetic waves that can interfere with the waves we use. So there are defined frequencies that are permitted for use in industrial and medical applications worldwide, and 6.78 megahertz is the highest we can use, since anything above 10 megahertz generates heat through resistive heating, where moving electrons collide with ions around them, creating friction and heat. At frequencies above 10 megahertz, dielectric heating occurs due to electromagnetic waves, making it challenging to control the amount of heat generated. Frequencies of 13 megahertz or 27 megahertz are unsuitable because they mix resistive heating with dielectric heating, making it hard to control the heating process. At 40.68 megahertz, resistivity drops and only dielectric heating occurs. This frequency range is where we can only use dielectric heating, which is used in devices like TuneFace and Polygen. Newer devices, like Onda, use a frequency of 2 gigahertz, which relies solely on dielectric heating. In other words, when electrons move at about 2 gigahertz, they generate waves that cause water molecules in tissues to vibrate, creating heat. Therefore, the highest frequency used in conventional resistance heating methods is 6.78 megahertz. That's why the Thermage, Olrigio devices, use a frequency of 6.78 megahertz. The problem is the penetration depth we talked about earlier. If the frequency is too high, it can't penetrate deeply, so we need to consider ways to increase the penetration depth. The factors related to this depth include high frequency, temperature differences between the epidermis and dermis tissues, tissue differences, or larger electrodes. Since the epidermis and dermis tissue of the patient and the frequency have already been determined, we are left with two options. One is to create a temperature difference between the epidermis and dermis, and the other is to increase the distance between the electrodes. So let's take a look at the difference when we create a temperature difference between the epidermis and dermis. When we cool the epidermis at the 2 millimeter point of the dermis and compare it with when we don't cool it, we can see that the current density or the amount of charge is much higher when we cool the epidermis. This means that we now pull the current with alternating current. Since the epidermis has a high voltage, the electrons in the dermis gather a lot, which generates a lot of heat. As the temperature rises, the resistance decreases, so the current flows better. So by cooling the epidermis, the electrons gather more in the dermis and generate more heat, and we call that reverse thermal gradient. In this case, the dermis becomes much hotter than the epidermis. Creating this reverse thermal gradient is the core technology of termage, and the biggest advantage of using the 6.78 megahertz monopolar high-frequency wave. To implement this, various technical aspects need to be considered, such as selecting the properties of the membrane of the tip, the type of metal or plastic to be used, and how to implement cooling. This involves a high degree of technological expertise. So we have covered the reverse thermal gradient, which is one of the greatest advantages of Thermag that Oligio succeed. Another technique is volumetric heating. It can be said that a bulky heating was implemented up to 4.3 millimeters by increasing the tip size. And then there was a disadvantage that we couldn't control the cooling system. It was fixed at 20 milliseconds, which was not adjustable, and this was a significant drawback of the technology. We can increase the duration of the cooling system for Oligio up to 80 milliseconds. In the picture here, we can see that when cooled for 40 milliseconds and when cooled for 80 milliseconds, the heat is significantly reduced more in depth. In other words, by creating a larger temperature difference between the epidermis and dermis, we can more effectively heat the dermis and penetrate deeper. Next will be moving technique. The technique is called moving technique, and it's done in auto mode. By pressing orange color button, the procedure can be done automatically and comfortably. This is another significant advantage because we have a patent for it, which means other companies cannot replicate it. I believe this will greatly enhance the convenience of practitioners performing the treatment. Oligio does not have time limitation like Thermage has only for 2 hours, which means that treatments can be divided into multiple sessions using treatment tips. Next, because the energy level is now divided into several stages, the pain can be significantly reduced. You know, previously with Thermage, people have to come mentally prepared to endure the pain, but now that disadvantage has been eliminated. So let me share my clinical experience. Typically, when we grade wrinkles in photos during conferences, we consider various factors. For mid-face wrinkles, we usually consider the jugular line. If it's visible, it's mild. If it passes the natural margin of the ale and the upper margin of the ear, it's moderate. And if the nasolabial fold is visible, it's severe. Then, next we focus on the jawline angle and neck angle to discuss the wrinkles. Company provides the materials available show pictures of the jawline and neck angle with improved effects 4 weeks after the procedure. Likewise, this demonstrates the improvement effect 4 weeks after the procedure. This is right after the procedure. It demonstrates the improvement generally around neck area. Oligio usually targets the dermis, while HIFU targets the subdermis, so I need to somehow stimulate the epidermis. That's why I use oligo 300 shots, HIFU 600 shots or more, and picofractional MLA lens to stimulate the epidermis. I perform a combination treatment using these 3 methods, and after 6 months, patient satisfaction significantly improves. I take photos at 8 months, 1 year, and 1.5 years after treatment. Among the monopolar RF devices, I believe that the 6.78 MHz Thermage is commonly used nowadays. Additionally, Tensorma is now also available in the market, which I think will further expand the market. Origio's new product, Origio Exu, came out and is currently on sale. The biggest feature is that the existing product has a power of 100 watts, while the new Origio X has a maximum output of 400 watts. The Origio X has a more powerful and stable output. I think that monopolar RF devices like this may become similar to laser toning equipment if they have lifting and tightening effects. This sums up my lecture.